Wiring lighting circuits with a shared neutral, as described, presents several concerns primarily centered on safety and compliance with the National Electrical Code, or NEC. Firstly, NEC 300.3b addresses the issue of conductors of different circuits occupying the same enclosure, raceway, or cable. The specific wording states that conductors of different circuits shall not occupy the same enclosure, raceway, or cable, or be run in the same cable or raceway except as permitted in 300.3b through b4. This means that in most residential wiring scenarios, you cannot have two separate circuits sharing a single neutral within the same cable. In the scenario described, two lighting loads are sharing a common neutral down a 14/3 cable back to the switch box. Since these are effectively two separate lighting circuits, this configuration violates the general rule stated in NEC 300.3b. The exception clauses 300.3b through b4 do not typically apply to standard residential lighting circuits. These exceptions primarily deal with situations like control circuits, modifications to existing installations under specific conditions, or multi-wire branch circuits, which are intentionally designed to share a neutral but are wired in a very specific manner to ensure safety and proper operation, which is not what is being described. Secondly, NEC 404.2 provides that every circuit shall originate at a distribution panel board or other approved source, and each circuit shall terminate in a single circuit breaker or fuse. The configuration in question, with two lighting loads sharing a common neutral, fails to meet this requirement because the two lighting circuits are not independently protected by separate circuit breakers or fuses all the way back to the panel. Instead, they are merged at the neutral point within the 14/3 cable. This is problematic because if one circuit experiences an overload or short circuit, the single circuit breaker protecting the overall circuit might not trip quickly enough to protect the other lighting circuit and the shared neutral conductor. Safety concerns are also paramount. If one of the lights fails, specifically shorts out, this could potentially cause the other light to also fail or malfunction. This is because the shared neutral is now carrying unbalanced current, and any fault on one circuit can affect the other. More seriously, this configuration could create a potential fire hazard if the current in the neutral wire exceeds its rating. The 14 American wire gauge, or ALC, wire used in 14/3 cable is typically rated for 15 amps. If both lighting circuits are drawing close to their maximum allowable current and one circuit develops a fault, the neutral wire could be carrying significantly more than 15 amps. This can cause the wire to overheat, potentially melting the insulation and creating a fire hazard. In addition to the code violations and safety risks, there are also practical issues with this type of wiring. Troubleshooting becomes significantly more complicated. If one of the lights is not working, it can be difficult to determine whether the problem is in the switch, the fixture, or the shared neutral. It can also lead to nuisance tripping of the circuit breaker if the loads are not balanced properly. The recommended and code-compliant wiring method is to use separate 14/2 cables from the switchbox to each light fixture. This ensures that each lighting circuit is independent and properly protected. Connect the neutral wire from each fixture to the neutral bus in the switchbox. This configuration allows each circuit to operate independently, minimizes the risk of overloading the neutral wire, and makes troubleshooting much easier. In summary, sharing a neutral between two lighting circuits on a single 15 amp circuit is generally not allowed by the NEC due to violations of 300.3b and 404.2, poses significant safety risks, and can lead to practical problems. It is essential to wire lighting circuits in accordance with the NEC and to prioritize safety when working with electricity. Always consult with a qualified electrician if you have any doubts or questions about electrical wiring. Proper grounding is also essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing the circuit breaker to trip quickly and prevent electrical shock or fire hazards. Make sure that all metal boxes, fixtures, and appliances are properly grounded in accordance with the NEC. Consider also the ampacity of conductors. The ampacity of a conductor is its current carrying capacity. The NEC specifies the ampacity of different sizes of conductors based on their insulation type and operating temperature. When selecting conductors for a circuit, it is important to choose a size that is adequate to carry the expected load without overheating. For example, a 14 AWG copper conductor with type TW insulation is typically rated for 15 amps, while a 12 AWG copper conductor with type TW insulation is rated for 20 amps. It's also worth mentioning about voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Another point is arc fault circuit interrupters, or size. A size are circuit breakers that are designed to protect against arc faults, which are dangerous electrical arcing conditions that can cause fires. The NEC requires a size in many areas of the home, particularly in bedrooms. When installing or modifying electrical circuits, it is important to use the proper wiring methods and materials. This includes using the correct type and size of conductors, connectors, and boxes. It also includes following the NEC requirements for cable support, protection, and routing. Be sure to also understand about ground fault circuit interrupters, or GFCIs. GFCIs are devices that protect against ground faults, which are electrical faults where current flows through an unintended path to ground. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor areas. They work by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference of more than a few milliamperes, the GFCI will trip, cutting off power to the circuit and preventing electrical shock. Also important is electrical panel labeling. Proper labeling of electrical panels is essential for safety and troubleshooting. Each circuit breaker should be clearly labeled to indicate the loads it serves. This makes it easier to identify and energize circuits when performing maintenance or repairs. The NEC requires that electrical panels be labeled in a clear and legible manner. For wire connectors and terminations, use only approved connectors and terminations for all electrical connections. This ensures that the connections are mechanically strong and electrically sound. Avoid using wire nuts on solid wire or making connections outside of approved enclosures. It is also important to tighten all connections properly to prevent loose connections, which can cause overheating and electrical failures. Do not forget about conduit fill. When running conductors and conduit, it is important to follow the NEC requirements for conduit fill. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. Overfilling a conduit can make it difficult to pull wires, damage the insulation on the conductors, and reduce the conduit's ability to dissipate heat. The NEC specifies maximum conduit fill percentages for different types of conduits and conductors. When working with electrical systems, always follow safe work practices. This includes energizing circuits before working on them, using appropriate personal protective equipment, or PPE, such as gloves and eye protection, and testing circuits to ensure they are de-energized before touching them. Never work on live electrical equipment unless it is absolutely necessary, and then only with proper training and precautions. Consider surge protection. Surge protection devices, or SPDs, protect electrical equipment from voltage surges such as those caused by lightning strikes or power line disturbances. SPD are available in a variety of types and sizes and can be installed at the service entrance, at branch panels, or at individual equipment locations. The NEC recommends the use of SPD to protect sensitive electronic equipment. Regarding electrical permits and inspections, in most jurisdictions, electrical work requires a permit and inspection by a qualified electrical inspector. Permits ensure that the work is done in accordance with the NEC and local codes. Inspections verify that the work is safe and code compliant. Before starting any electrical work, check with your local building department to determine the permit requirements. Furthermore, understand the short circuit current rating, or SCCR. The SCCR is the maximum short circuit current that a component or assembly can safely withstand. It is important to select components and assemblies with SCCRs that are adequate for the available fault current at the point of installation. Using components with inadequate SCCRs can result in equipment failure, electrical shock, or fire hazards. Additionally, one must understand the equipment grounding conductor, or EGC. The EGC is the conductor that connects the non-current carrying metal parts of electrical equipment to the grounding electrode system. The EGC provides a low impedance path for fault current to return to the source, allowing the circuit breaker to trip quickly and prevent electrical shock or fire hazards. The EGC must be properly sized and installed in accordance with the NEC, and also the grounding electrode system. The grounding electrode system is a network of interconnected grounding electrodes that provide a connection to the earth. The grounding electrode system helps to stabilize the voltage to ground and provides a path for fault current to return to the source. The grounding electrode system must be installed in accordance with the NEC and must include a grounding electrode conductor that connects the system to the service equipment. The neutral conductor carries the unbalanced current in a 3-wire, single-phase system. The grounded conductor is intentionally connected to ground at the service entrance. This connection provides a reference point for the electrical system and helps to limit voltage to ground. The size of the grounded conductor must be in accordance with the NEC. It is crucial to also consider the overcurrent protection. Overcurrent protection devices such as circuit breakers and fuses protect electrical circuits from overloads and short circuits. Overcurrent protection devices must be properly sized and installed in accordance with the NEC. The size of the overcurrent protection device should be based on the ampacity of the conductors being protected. Consider too the importance of working space and access. Adequate working space and access are required around the electrical equipment to allow for safe operation and maintenance. The NEC specifies minimum working space clearances for different types of equipment. Working space must be kept clear and unobstructed. The NEC also requires that electrical equipment be readily accessible, meaning that it can be reached without having to climb over or remove obstacles. And lastly, remember to understand the dangers of aluminum wiring. Aluminum wiring was used in some homes in the 1960s and 1970s. Aluminum wiring can be a fire hazard if it is not properly installed and maintained. Aluminum wiring expands and contracts more than copper wiring, which can cause connections to loosen over time. Loose connections can overheat and cause fires. If you have aluminum wiring in your home, it is important to have it inspected by a qualified electrician and to take steps to mitigate the risk of fire. Options include replacing the aluminum wiring with copper wiring, using approved connectors and terminations for aluminum wiring, and applying antioxidant paste to connections to prevent corrosion. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Improper electrical work can be dangerous and can result in electrical shock, fire, or other hazards. Always follow the NEC and local codes when performing electrical work.